Okay, AP style question number 3 about arsenic pentafluoride is that we begin with, not with equilibrium, but them just telling us that we have this many grams of arsenic pentafluoride. It's in a 10.5 liter container and the temperature is 105 Celsius. So what's the initial molar concentration in the container? And what is the initial pressure of the arsenic pentafluoride in the container? That means when there's nothing but arsenic pentafluoride there. So for the first one, that's simply that we take the concentration of arsenic pentafluoride would have to be the moles divided by liters. To get moles, I have to take my grams and then multiply it by 1 over the molar mass. This whole thing on the top would give me moles of arsenic pentafluoride divided by the volume that it's in, and we end up with a 0.0313 molar arsenic pentafluoride. That is part I. Then what's the pressure? Well, if I know the moles, I could put it into the ideal gas law. But more importantly, the ideal gas law, when I rearrange it to solve for pressure, I end up with this, N over V. Right, now, N over V is molarity, so I can substitute this right into there. And when I use that answer in 1A and substitute it in, there it is, I end up with the molarity times R times T. Notice I did turn that into Kelvin. You'll have the wrong answer if you don't. And the partial pressure, or actually it's all the pressure at this point, but the pressure from the arsenic pentafluoride is 0.971 atmospheres. Then we're given the decomposition equation. This is an equilibrium. And now we need to write the equilibrium constant expression. So this should be very simple. It's 1 to 1 to 1. There's no exponents. It's simply concentration of products over concentration of reactants. Easy point. Once you get to equilibrium, 27.7% of the original number of moles of arsenic pentafluoride is gone. So what's the molar concentration of arsenic pentafluoride at equilibrium? And then using those molar concentrations, calculate the value of K. So the first piece of this is very straightforward. If I had 0.0313 moles per liter and I lost 27.7%, that's what this is doing. It's figuring out what's it like if I lose 27.7%. So at equilibrium, I would only have 0.0226 moles per liter of arsenic pentafluoride remaining. You can go back a little bit more detail and figure out how many moles you have, then figure out how many of those moles disappeared, and then calculate molarity, but it's not going to change since the volume of the chamber does not change. So you're going to get the same answer with a lot more work. In number 2, part II, I should say, first we know that the concentration of these two chemicals has to be the same because they're formed in a one-to-one relationship. And they have to be what is, they have to be the same as all of the arsenic pentafluoride that disappeared. So if I started with 0.313 moles and at the end I only had 0.0226 moles per liter, that means I must have made 0.00866 moles per liter disappear. That has to be the concentration of both my arsenic trifluoride and my fluorine gas. So now I just have to plug it into the Kc expression. And this is squared not because we have a coefficient 2, but because we have arsenic trifluoride times fluorine gas, and they're both the same number, so it ends up as a squared term. And this, of course, is the concentration of the arsenic pentafluoride that's left behind. My Kc is 0.00332, or you could write it this way, 3.32 times 10 to the minus 2. To find the mole fraction of F2 at the container at equilibrium, you have to remember that mole fractions are like percentages, and it doesn't matter what size that container is. So we can use the concentrations from part C. It makes it a lot faster because since I know all these concentrations from part C, I can simply put in that my concentration of F2 divided by my total molar concentration. So that's my arsenic pentafluoride, my arsenic trifluoride, and my fluorine gas. And I find out that the mole fraction is 0.217. As I said, you could do this finding each mole and then going through this process again, but it will get you the same answer.